Hi, this is Christopher Boucher, and I'm going to review a standard normal distribution question that deals with the term between, and it's probably going to be titled number 5. Okay, we'll get started. It says find the probability of a value that follows a normal distribution will be between 70 to 120 with a mean of 100 and a standard deviation of 10. Okay, so as I've mentioned before, we always want to write down what we know. And so a couple things that we know here. We have mu, we have our standard deviation, and then the x is going to be a little bit different on this one, so we'll do these first two. Okay, so it says find the probability of a value that follows a normal distribution will be between 70 and 120 with a mean of 100. So this is our mu. Mean of 100 and a standard deviation of 10. And then for our x value, we're going to do something a little different. Now, traditionally, what people recommend is you write down this scenario where it's something like this. You write down 70, and then you write down 120, and then you write down x in the middle, and then you go and you write in your inequalities so they make sense, and you have one statement that applies. So how would we do this? Let's see. We would do it being between 70. Okay, so it would be less than or equal to 70, and then your x would be so in this case 70 is less than or equal to x, and then x is let's see, it is less than or equal to 120. And that's the way I believe traditionally they teach you to do this. Now, what I recommend is we do it like this. We write it out so that our inequalities point towards our area of interest, which I've always promoted. And what we do is we do this. I already have this all written out, so that's why if you see me looking over away from the camera, so I don't lead you astray. So essentially what we're doing here is we have the two problems and we're writing them out like they're one statement, but it's this and that. And if you see the reason why we do this, it's so that our inequalities will point both towards the middle, and that's a big cue for the way that we solve this. Okay, so this is the what we know. Let's draw out our picture. Now in this case, we know that we're going to have lines on both sides. And then we just go and we fill it in. So we put mu is in the middle, and mu in this case is 100. So mu equals 100. And so on this side, on the right, we're going to write x is less than or equal to 120. And on the left, over here, x is going to be greater than or equal to 70. I'll scoot up a little bit. So what this does is it helps us solve this problem because our inequalities are both pointing to the middle. And if you have seen my other videos, I always recommend that we point our inequalities towards our areas of interest. And in this case, unless you're doing hypothesis testing, when you're doing hypothesis testing, we call this the rejection zone. But we're calling this our areas of interest. I'm not a very good artiste, but that'll work. So we know that we want to solve for both of these middle portions, and we do not want to solve for the tails. Okay, so now we'll get started. And the only thing now we really have to do is we have to work out our z's. So we have a z-score for both sides. Making sure I'm on the screen. As always, our z formula is x subtract mu over standard deviation. So we have x subtract mu over the standard deviation. I usually do low first, then high. So low would be 70. Mu 100. Remember, if we get negative z-score, that only tells us that we're on the left-hand side of mu. So when we look up on the table, we don't have a negative on our table that we use. And that's fine because it is a half table. So you have, it's just 0.5 is 1/2, 0.5 is the other half, and the whole table that I have set up as 0.5. So it's not a problem for us. Just remember, you're not going to find negative on the table. You just go and you solve for the number as if it's a positive. But if it's negative, it's on the left-hand side. Is where it's actually you're solving for. Okay. So then now on our upper edge, it's 120. Subtract 100. And then mu on both, standard deviation on both of these is 10. I'm starting to run into the problem, so I'm trying to cram. So the answers for both of these, we have -3 for the lower half, and then 2 for the upper. And then we're going to, and I'm going to have to draw some lines going down of these values. So these are our z-scores. That's what we calculated. So I draw the little arrows. Okay. So now we're going to go and take a look at our table. So the first thing that we're going to look for is -3. So -3, like I said earlier, we don't have a -3, but we have a 3, and that's what we care about. So we have 3.0. This is my annotated, it's all called an alternative table, and in the future I'm going to explain how we use these other boxes, the annotated parts that I added. So 3.0 is all we're looking for. So our answer is going to be 0.4987. 0.4987, remember that. Okay, 0.4987, and then now we want the value for 2. Now, if these sides were symmetrical, meaning the low side was the same degree less than mu as the high side is above mu, then we would just solve for z once, and we would have the low side and the high side, and they'd be the same numbers. And that may not be too uncommon, but sometimes they're different, and you actually have to do 2 calculations in this case. So our z in this case, we're looking for 2, and 2 is going to be 0.4772, which is right there. And because it's an even 2, then we just go and we pick the first one, and that's because it's the zeros up there. Okay. So back again, it is 0.4772. Okay, 0.4772, 0.4772. So now we have everything that we need to solve this. So this right here, this -3, this is our low end. I'm going to move this over. So this is actually our part right here. 0.4987. Then our high end is right here. It's because this is the positive one, this is the negative one. So it's going to be 2. So the obvious way we solve this is we add these two up, and that's our answer. And if we add these two up, our answer, like I said, I have this calculated out. This plus that equals 0.9759. And that's our answer. Now, if you do this on the calculator, what you want to do is you want to do your low end being the floor, which is 70. Your high end is your 120, and you would use the you would do second dist, and then so it'd be like this. It'd be the normal, right? CDF. And this is inside, this is for the TI-8384 calculator. And you would do second dist, so it'd be like this. Second. I think it's distr, D-I-S-T-R, something like that. And then you go and your, you would have a couple things. So your lower limit would be, 70, and your upper limit would be 120. And then your, of course, your standard deviation would be 10. Your mu would be whatever the mu is, which is 100. And I think that's it. And then you would end up getting an answer that's very, very close to this. So it's very easy. The betweens are very easy, in my opinion, because you know what your upper and your lower is. There's not a lot of guessing on that. So you put in your upper, you put in your lower, you put in your standard deviation, you put in your mu, and then you get the answer. So there's not a lot of wiggle room there. One thing that I've dealt with before is, so when we talk about between questions, they're always going to be on the middle part of the distribution. So what I mean is the values that we calculate out are going to be butting up to the middle part of the distribution, not the tails. So if you can think about it, it would be very odd to have a question that said, what is the probability that something will be lower than 70 and higher than 120? So you go and you say, well, it doesn't really work that way. So it's an odd occurrence if you think about it, that something would be higher or lower, but it can't kind of be both. Now this could be higher or lower, but we just usually don't deal with it when there's we're solving for the tails and we're not solving for betweens. We're always solving for this part. It would be an type of weird question where we're solving for the not between, and we just don't go there in this class. So that's all I have. Thank you.